In this video, I will illustrate how to use a t-test in Microsoft Excel, and then how to use the output from that t-test to make a graph to demonstrate to display your results. So these data that I have here are data on the basal metabolic rate, or BMR, of male and female mice. So I have a list of male numbers and a list of female numbers. So when we're looking at these data, we're interested to know whether the male BMR is different from the female BMR. So to determine that, we're going to calculate the means, and I can have Excel calculate those means this way by putting in a formula equals average. I'll select that, choose this array of data, close my parentheses. So the average BMR for the females is 6.75. There's probably too many decimal places there, so I'll decrease that a little bit. Two numbers after the decimal is probably fine. Then I will just drag this small box over to fill in for the females, and we see that the females have, on average, a little bit higher BMR compared to the males. What we're interested in knowing is whether this difference is actually significant. So when we have two sets of data like this, we can perform a t-test. In Excel, you can find the t-test under the Data Analysis tab. So if I just click on this, and I'm going to choose a two-sample t-test, assuming unequal variances. I have a fairly small number of individuals that we tested, and so it's likely that the variance between these two groups is not equal. So to be conservative, we'll choose an unequal variance. And this is two-sample because these were different males compared to the females. So all of these are different individuals. So then I'll click OK, and I'll end up with a dialog box. And it's going to ask me to choose my variable 1 range and then my variable 2 range. So to choose my variable 1 range, I click on this little colored box. I'm going to choose all of the male data, including the heading. And then I'll choose all of the female data, including the heading. And I've checked this box here because I do have labels in my data. An alpha of 0.05 is fine. And then I've selected an output range of, I think I'm going to change that. So an output range, I would like my output to be starting right here in F2. And I've put everything in, and so I can go ahead and click OK. So this procedure in Excel puts out a table like this. The table includes the mean, the variance, the number of observations, so there were 7 in each, the degrees of freedom, which basically is the total number of individuals minus 1 for each group. So 14 individuals minus 2 gives me 12. And then it gives me the t-stat, which it then compares with a critical t to calculate my p-values. So this p-value here that we'll use is the two-tail p-value, which is saying that we don't have any preconceived way of knowing whether the male BMR would be larger than the female or whether the female would be larger than the male. So we'll go ahead and use a two-tail test. So this p-value, 0.15, is greater than our critical p-value of 0.05. So we would say that the difference between these two means is not statistically significant. Now, we can also use this output to make a graph. So it couldn't be much easier. You just select these 4 cells, go into your Insert tab and insert this graph. And so now we have a graph that shows the male mean BMR and the female BMR. We will add a label for the axis. We want a primary vertical label, and what we would like to say is mean metabolic rate. And then I'm going to put in my units, which is gram calories per hour per square centimeter. Since you can't do a superscript in Excel, I'll just use a hat and 2 for my square sign. So there's my y-axis label. The x-axis doesn't really need a label because we have the male and the female here. Okay, now it's also good to put in error bars, and we want to calculate error bars. So I'm going to add a row here. I'm going to insert a row, and I'm going to calculate standard errors based on the output that I got from my t-test. So the formula for standard error is equals the square root of the variance divided by the number of observations. And I can close that parentheses. That gives me my standard error. And go ahead and drag that across to the female column. And then I have calculated standard errors for each group of data. Now, to add those standard errors as error bars in my chart, I will click on add an chart element. I will click on this arrow next to error bars, and I'm going to choose more options. And then I will scroll down in this dialog box. I will choose custom, and I want to specify the values that I just calculated. So the standard error are these 2 boxes, and that's for both the positive and the negative error value. And I'm going to click OK. And you can see I have nice error bars. Now you will see that these error bars, it looks like they do not quite overlap, but they're close. But my statistical test tells me that these 2 means are not statistically significant. The difference between these 2 means is not statistically significant. So that's how you perform a t-test. That's how you use the t-test to make a graph that you can then add to a lab report.